In this session, we'll start the second part, that is ProE integrated. First, we'll see the syllabus of this ProE integrated. As per the syllabus, the first one is the advanced features of solid modeling, and the second one is surface modeling. The third one is sheet metal modeling. The fourth one is mold cavity preparations, that is pro molding, and the last one is manufacturing. And in the manufacturing, we are going to deal with lathe and mill machines. So this is the syllabus of part 2, and now we'll start with the first feature, that is helical sweep. Go with insert, and here we have helical sweep, and this helical sweep is used to create the springs, because the springs are going to have the helical path. So here we are going with helical sweep. So in helical sweep, again just like sweep and blend, here also we have to select first whether the protrusion or thin protrusion or surface. So if I want to create a solid spring, then I can go with helical sweep protrusion. Let me go with protrusion. Then whenever you are going with helical sweep protrusion, here it is going to give you a menu manager along with helical sweep protrusion dialog box. Now in this dialog box, it is asking first about the attributes, and we are going to define the attributes using this menu manager. Now in this menu manager, if you see here, totally we have 6 options. The first one is constant and the second one is variable, and these 2 options are related with the pitch. Whether you want to create the spring with a constant pitch or with a variable pitch, that we can decide by going with any one of the first 2 options. And after selecting any one from these 2, you can go the next 2 here, that is through axis and normal to trajectory. And these 2 options are related with the normality of the section. So how you want to place the section, based on that we are going to select here either through axis and normal to trajectory. And the differences between these 2 I will show you after creating the spring. And next we have 2 more options called right-handed or left-handed. Already we know what is right-handed and left-handed. So same thing here also, whether you want to create a right-handed spring or left-handed, that you can choose here. Now first let me go with the default option, that is constant, through axis and right-handed. Then I am going with done. And after defining here the attributes, you can see now it is asking about the sweep profile. That means now we are supposed to sketch the sweep profile, and for that it is asking to select a sketching plane. Let me select the front plane, and about the direction I am going with OK here. It is asking about the reference and orientation. Let me go with default. Now in case of helical sweep, we have to draw one center line. So center line is compulsory in helical sweep. So let me place one center line, and this center line is going to act as the axis of the spring which we are creating. So this is just like the axis of the spring. And after creating the center line, next we have to draw the sweep profile. First let me take a simple line as sweep profile, and here I am maintaining a gap of 100 between the center line and the sweep profile. And let me take the height of the line as 500. Now these are the dimensions of the sweep profile. And after creating the sweep profile, you can see here, even for this profile also we have a start point. Because it is sweep, we are going to have the start point. If you want to place the start point at the bottom, the procedure is same. You can select the bottom vertex, right click, and you can go with start point. So place the start point wherever you want, and after adjusting the start point, now we have to go with OK. So with this, the sweep profile is completed. And after completing the sweep profile, now you can see here it is asking about the pitch. Because it is spring, we have to define the pitch here, and at the bottom it is asking about the pitch, and by default it is taking as 50. And this default value depends upon the size of the sweep profile. Now let me take the pitch as 30. And after defining the pitch, now at last we have to define here the section. And let me take the section a simple circular section. I'm drawing here a circle and the diameter I'm taking 25. A circle of 25 diameter. Then after completing the section you can go with OK here. So with this we have defined all the 4 items whatever we have here in this dialog box. Then next we can go with preview. See the preview. So this is the spring which is created according to the given parameters. And let me hide all the planes and axes. Now you can see the spring clearly. And here we got a straight spring because I have taken a straight line. So the diameter depends upon the sweep profile. And here I have adjusted the distance between the line and the center axis as 100. So now the radius of the spring is nothing but 100 here. The radius is 100 and the section I have taken a circular section. So here we got the cross section of the spring as a circle. And I have given a constant pitch of 30. So now if you see here the distance between any two adjacent coils, the center to center distance you can take, that is exactly 30. So this is how we can create the spring by specifying all these parameters. Now let me go with OK here. So a spring is created. So once again you can go through this. Let me delete this one. Again I am going to insert, helical sweep, protrusion, and select the attributes, constant, through axis, right handed. Then we have to select one sketching plane to define the sweep profile. And first we have to place the center line. Then we should place the sweep profile. And the distance between the center line and the sweep profile is going to act as the radius of the spring. And this length of the line is nothing but the height of the spring. If I take here the length of the line as 400, then I am going to have a spring of height 400. Then if you want to shift the start point, you can shift it, as we know how to shift the start point. Then after completing the sweep profile, you can go with OK here. Then define the pitch. Now let me take the pitch value as 100. Then draw the cross section. Now again I am taking here a circular cross section. You can take any cross section, but here I am taking the simple one, that is circle. And I am maintaining the diameter of the circle as 30. Then accept it and see the preview. Now because I have taken the pitch value as 100, now you can see the distance between the coils. Now once again let me go with pitch, say define. Now I am going to increase the pitch value to 200, then see the preview. So when I am increasing the pitch, the number of coils are going to be reduced. The number of turns will be reduced here. Now once again let me increase the pitch value. The pitch value will take 300 and see the result. Now once again I am going with pitch, say define. Now it will take a smaller value. Let me go with 40. Then you can see the preview. Because I am taking a smaller value, the number of turns will be increased like this. So this is about the pitch. And here I have taken the attributes as right-handed. So you can see here the spring is of right-handed spring. So you can see continuously it is moving towards right. So this is nothing but a right-handed spring. Now if I want to change that right-handed spring to left-handed, I can use here the attributes. Let me go with once again the front view. Now I am going to attributes, so define. Then let me select here left-handed, go with done and see the preview. Now the spring is moving from right side to left side. Like this we can change right-handed or left-handed. Then in the attributes, we have normal to trajectory and a variable pitch. So these two options we will see in the next session.